This is Lesson 8, titrating a strong base with a strong acid. So this titration curve shows 50 mLs of sodium hydroxide being titrated with 0.25 molar nitric acid, and we can find the sodium hydroxide molarity from the titration curve. So first of all, let's take a look at this titration curve, and I'm going to put up the titration curve from the set that we just did, and notice that these are virtually mirror images of each other. Here we started with a strong acid, and so we had a very low pH. Here we started with a strong base, so we have a very high pH. The equivalence point for both of them is 7. Because they're both strong acid, strong base titrations, we're just flipping which one is in the flask to start with. So we have the reaction of sodium hydroxide reaction with HCl. In the flask this time we have the sodium hydroxide. We're adding the HCl. Our net ionic equation is again H plus OH minus is producing H2O. And let's take a look at the characteristics of this curve. So the initial pH is going to be very, very high. And in fact, we can take 10 raised to the negative pOH to figure out the initial concentration of our hydroxide. So if our pH was 13, then our pOH would be 1. Okay, so remember that you have to, pH plus pOH is equal to 14. Our equivalence point is going to be 7. The pH is going to decrease very slowly for the first 90% of the way up to the equivalence point. The equivalence point is always going to be at 7. Once we've reached the equivalence point in this steep change on the pH curve, that's how we detect the equivalence point. This is our equivalence point in terms of mLs. So we would use the volume of base of 30 mLs. So we can calculate the concentration using MAVA equals MBVB. And then once we are after the equivalence point, the pH is going to decrease because we have excess H plus as our reagent. So let's go ahead and solve the concentration problem. We have MAVA equals MBVB, and we are told that we have 0.25 molar HNO3, so we have 0.25 molar for our acid. The volume of the acid, we were told it was 50 mLs right there, so we have 50.0 mLs. And that is going to be equal to the molarity of their base, that was 0.25 molar. Yep, I'm sorry, I messed up on that. That was not 0.25 molar. I was going back to the acid. I do not know the molarity of the base. That's what I'm trying to figure out. Let's try that again. So we're going to put an MB here. MB. And the volume of the base, I take off the endpoint here. It is 30.0 mLs. And so when I solve for the molarity of the base is equal to 0.15 molar. Okay, all the other calculations are going to be exactly like the ones that we did for the acid. You're going to end up setting BCA tables up and then calculating from there, remembering to always use total volumes.